So we've got a couple notes for homework 16 to run through. And it's basically three different variations of factoring that we just needed to review really quick. And so if we've got a normal quadratic like this, we want to try anyway the AC method. And if that doesn't work, we need to use the quadratic formula, which is kind of a pain. But let's see if the AC method is going to work. So we've got A times C, which in this case is 1 times 15, which makes 15. So factors of 15 are 1 and 15, and 3 and 5. We need to look for a pair that when we add them or subtract them, we get our middle term, which is 2. And so it looks like 3 and 5 will do that for us. We could have a positive 5 and a negative 3. And so we'll split this. We need a positive 5 and a negative 3. Again, factors of 15 that make positive 2. And we do our da-da-da-da-da. And then we can factor the left side, which would be taking an x out. We're left with x plus 5. And then on the right side, we want an x plus 5, so we recognize we need to take out a negative 3, which leaves an x plus 5 in there. And I'm going fairly quickly because this should be review. So we would be left with x plus 5. This would drop down here. This would come over here and join it because we can factor an x plus 5 out of both sides. And we would be left with x plus a negative 3. If we clean those signs up, we get x plus 5 times x minus 3. And so that would be how to factor a normal quadratic. Now, factoring a quadratic differently, there is a couple other styles. And so there is one that we called a difference of squares. And if you want to review that more in depth, I believe it is lesson 10. Let's take a look. Yep, homework 10 would be the difference of squares. That's a very specific type of quadratic that doesn't have a middle term. And so we would have x squared minus, it's always going to be subtraction, x squared minus 9, for instance. Now, I'm going to write over here in blue on the side what's really happening there. We really have x squared plus 0x minus 9. And if we were to do the AC method, we would have 1 times 9, which is 9. Factors of 9 are 1 and 9, 3 and 3. And so we would go, hey, what could we use to make 0? And it would be a plus 3 and a minus 3. Now, the idea behind difference of squares, or the reason we even use it, is because it saves us having to do all of that work. And I'm going to undo erasing that and leave it there in case you want to pause and look at that. And if you wanted to continue with that from there, you totally could. But the difference of squares is allowing us to not have to do that work, but instead remember that, hey, since the middle term is gone, it must be a positive 3 and a negative 3, because 3 times 3 makes 9. It's a perfect square. So x squared plus 3x minus 3x minus 9. Then we would factor out of the left side an x. And what would be left is x plus 3. Out of the right side, we would factor out a negative 3. What would be left is x plus 3. And again, we factored out a negative 3 so that we would have both of those be x plus 3 so that we could factor them out. And we would get x plus 3 times x minus 3. Now, because of difference of squares, there are many people who just see this and automatically jump straight to here. You don't even have to do the middle step. And so that's actually what I would encourage you to do as we work through these today, is just to get very adept at noticing, hey, this is a difference of squares problem. I can just basically go straight to the end and not have to worry about all that stuff in the middle. And then the last one, I don't know if there was a lesson on this one. The last one would be a perfect square, but we're actually not going to go into too great a depth on that one. Doing a variance on the one we just did, we would have something like x squared plus 6x plus 9. And we would recognize that the factors of 9 are 3. 3 plus 3 makes 6, and so we could jump straight to x plus 3 times x plus 3. Again, perfect squares is not necessarily something that's going to come up a whole lot in this lesson, but it bears bringing it up. Let's do another difference of squares really quickly just to kind of demonstrate how we can go straight from beginning to end. And so I'll do this one in blue. If we have x squared minus any perfect square, it could be 25. Let's do another one in green. X squared minus 36. And I recognize I forgot my squared on my blue one. With that blue one, I could jump straight to x plus 5 times x minus 5 because of difference of squares. And with the other one, I could jump straight to x plus 6 times x minus 6. Again, because of difference of squares. And so if you remember some of these little tricks, it will make today's homework 16, quite a lot easier, particularly the difference of squares.